Hello, everyone. So let me check to make sure that my audio levels are good. And looks like there's one person in the chat. Okay, we can start. So what I'm going to do today is just review what's on the test this Friday, and basically it's everything after the second test. Okay, so that's going to be the section on software development. Okay, so that's one thing, very short topic, but that's on the test. The other one is going to be word processors. Okay, and also spreadsheets. And then the last topic we did was databases. Okay, so that's what's on the test. All right, so shouldn't be too long a lecture, but Let me just go through what you should know for the test. Okay, so when it comes to software development, I wasn't so worried about teaching you about all the different software that's out there. You probably know more about the different types of like applications that are out there than I do, because you could just download them from the store, from the Apple Store, or from the Google Play Store, whatever. And so the more important thing is to understand, well, what is it that you're downloading? Like, where did this thing come from? How much should you trust it? And like, what's going on here? Okay, because a lot of them are free. So I told you a little bit about how software is developed, because that answers the question, like, where did that application come from? So software is basically developed by some developer, basically a programmer, writing in what's called source code. Okay, now source code is readable by human beings. Okay, it's not what the actual computer or phone runs, but it's readable by human beings, and that's really tells another human being that reads this code how the application works. It gives all the details. Okay, so people can look at it, they can study it, and so on. All right, and any application where they don't just give you the application, but they also make the source code available. All right, now you may not get the source code, or you may not want the source code, but they make it available to those who do. That code is called open source, okay, because the source is open. Now, why is that important for you to know? You're saying, well, I'm not a developer. Why should I care about this? Okay, it sounds like something that happens only in the geek world. I'm just happy to get the application. Here's why it's important: because you don't know what's going into that code. Like when you download an application, you really don't know what's in it, okay? And even if it's open source, you probably don't know what's in it, but other people do. And the reason is because the open source is open to the public. The source code is open to the public. There's people in the public that'll look at this and they'll go, wait a sec, what's this application doing here? Okay, so it's a question of trust. All right, like an application that you download could certainly spy on you. Hopefully, a reputable company doesn't do that. But open source can't do that, because open source makes their source code available, and so people can just see how that works. So if something is, if you know that a particular application is made by open source, that's definitely a positive, because it means that it's the tendency of it to do something malicious is mitigated by the fact that other people are looking at what that code does. Okay, the other good thing about it is that it doesn't cost money, although that's not really what open source means, but that's another thing. It doesn't cost money. All right, and probably one of the best examples of open source code is Firefox. Think about it: your browser, you're typing, when you go to a web page, you think, you go to your bank web page, you go, well, this information is going to my bank over the internet, over an encrypted communication, okay, or encrypted connection, and so I'm safe. But you don't know if Firefox itself doesn't get the password and then send it somewhere else. Okay, so yeah, the connection to your bank might be encrypted, but then an evil Firefox might be doing this, might be spying on you. Okay, well, it can't really, because we know how Firefox works. The source code is open. Okay. And then that's called open source. In contrast, software that you have to pay for, it's usually made by a company. They keep that code hidden. And the reason they keep that code hidden is because they don't want you to know how it works. And the reason they don't want you to know how it works, it's not necessarily that they're malicious, but they don't want to give away their secrets. The problem is by, keeping it hidden, there's always a suspicion, like, what is this thing doing on my phone? Okay, so there it is. Okay, so that's the difference between open source and proprietary code, and it's important to know that, because if you know that a particular program that you're downloading for your computer or your phone, laptop, whatever, is open source, it gives you a little bit more confidence that they weren't able to sneak something by you. Okay, and so there it is. The only thing I didn't write down here, and that you should probably know, is that open source, even though it's free and it was developed for free, okay, it has a lot of mind power behind it, because there's a lot of developers that look at this code, and I looked at code for programs that I don't even necessarily like write code for it, but I'll look at it every once in a while and I go, oh, I could fix this here, or I can improve that there. And I think I showed you that when we went through this section for Tor. That's the Onion router stuff for privacy. So I looked through the Tor code and I noticed some places where I could fix it, and so I submitted my fixes and they were accepted, and that made Tor just a little bit better. Okay, and so I mean, it doesn't take that long, and I'm just one developer among many. So open source has a lot of mind power behind it. Okay, I didn't put that here, but it's pretty good quality stuff. Linux, like Android, is open source, mostly open source, mostly open source. Okay, just to give you an idea. Okay, well, that's enough for software development. It was a short section, but I did want you to know where these applications and programs are coming from. Just so you like, because when you're installing them on your phone or your computer, you don't want to be installing something that you don't know what's going on. Okay, it's kind of the point of the course, is that you're an intelligent user of computers rather than someone who just uses them without knowing what they're doing behind the scene. Okay, the the rest of the course was on Office software. Okay, and I didn't pick Microsoft Office or I didn't just do LibreOffice, although in my demonstrations I use LibreOffice, but what I showed you will work on any Office suite. Okay, might be some small differences in details, but all Office software more or less does the same thing, and it's made up of at least 3 programs, although probably a 4th. Okay, and so the programs are word processors, and I showed you word processors. We looked at LibreOffice Writer, but that's like Microsoft Word. Okay, and we looked at spreadsheet. Okay, and that's like Microsoft Excel, although I use LibreOffice Calc. All right, again, very similar. Now, if you have the home edition of Microsoft Office, you don't get a database. Okay, but if you have the the Office edition of Microsoft Office, you get a database. It's called Access. Okay. Now I used LibreOffice Base because I'm not going to pay $500. I guess I could have got to college to do it, but I'm just not going to pay $500 for a databasing program that I'm just going to use to teach. Okay. And so the databasing program I showed you is called LibreOffice Base, but it's almost identical in Access for Microsoft Office. It's called Access, and it looks almost identical. Okay, and anyhow, with databases, it's not so much that the program is difficult; it's the design of databases that are difficult. And I think you might admit that section was a little bit of a brainful. It was kind of hard to really see what's going on. But hopefully, by the end of this lecture, you'll understand the database concepts a little bit better. Then there might be some other things, but usually the only other program that's in there is some kind of presentation software, and that's like PowerPoint. It's just stuff that you can like do a presentation or like with a projector or something like that, so that you could show your office colleagues, I don't know, whatever you're working on. Okay, so though the presentation software, I didn't go over it. It is really simple to use. I'm more than confident that you would be able to figure that one out on your own. Okay, the database you would not, for sure, and I'm not sure that you would ever go off and design databases. So you will use word processors, and you probably have used word processors before. Spreadsheets, you may have used them before. Hopefully now you have a better understanding of how they work. You probably will never design a database, but at least understanding its internals will help you, because like I'm just going to take a guess that maybe you'll be in the medical profession, and if you work in a hospital, it's all the information in a hospital is driven by a database. So you can see these numbers running all over the place, and now you have a better understanding of what all these numbers are doing. Okay, more than just an intuitive understanding. Okay, so there it is, and the database is the central engine from which all the other pieces can pull information. Okay, so I showed you at the very end of our database section how you can use that to do what's called a mail merge, and that is you write a template letter, and you just say, okay, this letter is like going to go to 500 people. Well, you just write that letter once, and then you ask the database to fill in, where the first name goes and where the last name goes. And if it's 500 people, it'll just take that one template and reproduce it 500 times, each one personalized for each person that you're sending it to. And so that's a real time saver. Okay, and so there's a question that you can ask about productivity software, or Office software. It's sometimes called productivity software. You can ask something about it, and you could say, well, does it speed things up for me? Does it make my Office run smoother? Well, obviously it does. Otherwise, Microsoft would not have been able to sell Microsoft Office. Okay, so obviously it does, but there's a specific way that you can characterize how much it speeds things up. Okay, so we'll talk about that a little bit later when we get to databases. Okay, so let's start in with word processors. So word processors, again, you've used them. I just wanted to show you how to use them well. And to use them well, you should understand that really the major point of a word processor is to format your text so that it looks good. Okay, that's it. You know, like there are the text editors, which actually what you're seeing right now, this text in the background, that's not a word processor. That's just a text editor. And so the letters, they're just plain. I can't make bold letters here. It's not like I can, you know, highlight this word levels and make it bold in my text editor. Text editors just work in ASCII. That's it, period. Whereas word processors actually do the formatting. So the formatting can be done at 3 different levels. You can format at the page level. That is, you can format the entire page. And you usually don't have to do that because we tend to send papers electronically to one another. But if you have to print it out, you have to make sure that the Word document that you're using matches the page size of what you're printing out. Otherwise, it'll look funny. Okay, if you print an 8.5 by 11 on a 8.5 by 14, you're going to have a lot of white space at the bottom of that page. Okay, so yeah, you know, that's about it for the page. Okay, not too much. I didn't go into it a lot. There's the character level, which almost everyone knows, and that's like doing something like you want a word to be bold, or you want one letter to be bold, or you want it to be italic, or you want to change the font. You know, you find your font a little bit plain. Like the typical default font is like Times Roman, okay? But you want something else, okay? So you can change the font style, you can change the size of the letters, you could change whether it's bold, italic, it's called emphasis, and so on. You can all do that. You can do that sort of stuff. You can do it on a single letter. You can do it on groups of letters that you've highlighted. All of that is called character level formatting, okay? That's it. So that's what you could do with characters. But there's more than that. The most important one is usually the paragraph level, and that's the one that most people don't know about because they just start typing and they hit return when they need to go to a new paragraph. And then, you know, if you cut and paste in there, things start to look funny and you'll go, what's going on? The paragraph is basically, you know, the basic repeated unit throughout the entire a paper, and so you want to make sure that all of your paragraphs look the same, and that gives the uniform format to the entire paper. Okay, so you want to basically make sure that you get your first paragraph right and format it correctly, and the paragraph formatting allows you to you know, decide whether or not you want to indent the first line of your paragraph. You know, like when you're writing prose, you indent the first line. Usually, I think it's like 1/2 inch, okay, something like that. Or sometimes you want to indent the left and the right side of the body of the paragraph, okay. And also you want to put some space between paragraphs. That's called the interparagraph spacing. But also within the paragraph itself, you want maybe like a single line spacing, or 1.5 times, or double spacing, or whatever. That's called intra-paragraph spacing. And you know, all of that can be set through the paragraph menu. Okay, now once you've got your first paragraph right, and then when you type it in, when you hit enter, it goes and it creates a new empty paragraph. That new empty paragraph, okay, that new empty paragraph has the same formatting as your previous paragraph. And that's a good thing, because that means that when you type your next paragraph, it's going to have the same formatting as the previous one. Then you hit enter, and then now you're in your third paragraph, and you keep typing, and you get the same formatting as all the other paragraphs. And this way your entire paper looks uniform. It has this uniform formatting to the paragraphs. Okay, I've seen a lot of papers where, you know, the paragraphs were all wrong. Okay, and another thing that students try to do is they try to like indent that first line using a tab. And the problem with tabs is that tabs, I mean, I know this sounds funny, but you know, tabs, they're not of a fixed size. They're different sizes. You can actually set the size of the tabs. That itself is formattable. And so if you have tabs that are formatted with one size in one place and tabs that are formatted for a different size in a different place, it doesn't look good. Okay, so you let the paragraph formatting part of the word processor take care of that for you, and it'll look really good. That's probably the most important thing that you can take away from this part of the lecture on word processors. Okay, there's a special kind of paragraphs. These are paragraphs that begin with either bullets or numbers, and a bullet is just like some icon, like a little circle. Okay, you know what bullets are. And then numbers, you know, you can number things like point number 1, point number 2, point number 3. Okay, that's a special kind of paragraph. It's also formattable just like a paragraph, and it's a part of the paragraph formatting. But it's got this extra icon at the beginning. I mention it because when you want to get out of bullets and you want to return to the previous formatting, you actually have to hit the enter key twice. Okay, and so that's a little counterintuitive. You say, well, okay, I don't want any more bullets. I've got like these 5 bullets, and you hit enter and you get the 6th bullet, and you go, but I didn't want a 6th bullet. You hit enter again, and it'll snap back into the previous formatting. Okay, so there you go. That's bullets. And the other thing you should know about our tables. And tables, you can insert a table into your paper. They look like little mini spreadsheets is what they are. Okay, they're tiny little table in there, and of course it's got some rows and it's got some columns, and I showed you how to format those so that you can make that look nicely. Okay. The only thing that's not very intuitive about tables is you can delete the contents of a table by highlighting the contents and hitting enter, but then all you do is you leave behind that an empty cell, which is, you may want that. You may want like an empty cell in there. Okay, so the delete key just deletes the contents. It doesn't delete the cell itself. But suppose you have a row. Okay, like maybe your table is made up of 4 rows and you want to get rid of an entire row. So it goes from like 4 rows to 3 rows. You just want that entire row to go away. If you hit the delete key, all you're going to get is a blank row. You'll still have 4 rows, but one of the rows will be blank. And you go, well, I want to get rid of that row. I don't want to just get rid of the contents of that row of cells. I want to get rid of the cells themselves. And to do that, you have to use a menu item. Okay, so there's a menu item under the table menu. So it's a sub item within the table menu item that allows you to add and delete rows or columns. Okay, and that's the only way you could do it. All right. It's, by the way, this part here is the same in either a word processor or a spreadsheet, because in spreadsheets you might have an entire row that you want to get rid of. If you just highlight that row, okay, so that's like highlighted like with the blue highlighting that you see here. If I hit the delete key, that text, I'll do it right now. I'm going to hit the delete key like that. You see how that text disappeared. I'll put it back because I want it there. But like the row remains behind. But you say, no, I didn't actually just want the text to disappear in this row. I want the row itself to disappear, and then the spreadsheet, to fill in the gap where that row was. That you have to use a menu item for. Okay, and so I've seen students struggle with that because they're hitting the delete key and they're going, I can't make the row go away. Well, that's how you make the row go away. You need to use a menu item. Okay. What else can you do with word processors? Again, these are just random things that I picked that I know that students have asked me about in the past. Suppose you have to put a special symbol in there, like usually the copyright symbol. That's the C with a little circle around it, and you're looking on the keyboard and you go, I can't find the C with the circle around it, the copyright symbol. Well, there's under the insert menu, there's a sub menu, special characters, and it gives you this table filled with all these special characters, and you just pick the special character out of there. Okay, so that's how you can get these special characters. I've seen students actually go to web pages and then cut and paste from web pages. You don't have to do that. It's built into the into the word processor, but you have to go into this insert special character menu. Okay. The other thing that most papers will need are footers and headers versus footnotes and endnotes. Okay, and so we don't want to confuse these two, footers and headers and footnotes and endnotes. Okay, so what's a footer or a header? All right, so a footer is an area of text at the bottom of every page which is identical. Okay, so suppose you have a 10-page paper, and at the bottom of every page you want to put your name. Just put your name at the bottom of every page. You could just type it in manually, but then you'd have to type it in 10 times. Or you could just add this thing called a footer and put your name inside that footer, and it will be replicated in every single page. Okay, so once again, it's basically a footer is an area of text at the bottom of the page which is identical on all pages. Okay, it's repeated on all pages. The header is the same thing, but at the top of a page. So instead of saying you want your name on every page, but you don't want to put it at the bottom, you want to put it at the top, or you maybe want the title of the paper to be at the top, you can use a header for that. Okay, so that's what headers and footers are. Okay, they are these areas of text at the top or bottom of the page which is replicated on every page. Okay, a footnote and an endnote is basically a little label that's placed inside the body of the text that refers to text, which is either, in the case of a footnote, at the bottom of the page, or in the case of an endnote, at the end of the document. So like when you're reading a paper and then there's a little 1. If it's a footnote, you go to the bottom of the page, and at the bottom of the page, there's this little one, and there's the text that expands on that one that's inside the page. Okay, it's like inserting a little bit of text parenthetically inside of the paper. Okay, so basically the footnote is the little label, like the one, and it refers to text at the bottom of the page. The end note is the same thing. It's like a little one or two, or it's a little number, but it refers to a note which is at the end of the entire document, not at the bottom of the page. Okay, and don't confuse footnotes and endnotes with footers and headers. Okay, all right. So there we go. That's that. And a field is important. If you want to put a page number on every page, you could type it manually, but that would be horrible, because if you start inserting stuff in the middle of your text, then you're going to have to renumber your pages. Okay, so like when you write a paper, you might add a section in the middle of the paper, then you'd have to manually retype in all the pages. If you use a page number field, this thing called a field, you let the word processor fill it in for you. That's what a field is. A field is, you just say to the word processor, please fill this field in for me. You figure it out when you go to print this paper out. Okay, what number should go in there. By the way, I showed you the page number field, but if you have a database, you could use any field out of the database to inside your paper, and then your paper gets, or letter, or whatever you're typing, gets automatically filled with data that comes out of the database, and it fills in those fields. So you can have like a first name field and a last name field and so on. Okay, so then you're really making use of that Office software. All right. Okay, so that's what a field is, and generally it's used for a page number. Okay, although as I said, you can be used for other things too. Okay. Another thing is a page break. I've seen students that want text to go on the top of the next page, and they put a bunch of empty paragraphs in there. That's not a good idea, because again, as you insert stuff, you know that the text will float all over the page. So if you use a page break, what that does is it cuts the current page short, and it guarantees that the next thing that you type will go to always at the top of the next page. Okay, so that's what a page break is for. It basically ensures that the text immediately following the page break is at the top of the next page. Okay, so that's a better way to do it than to try to insert and delete paragraphs here, empty paragraphs here and there. Okay, and last thing is you should always have the let me fix this. Okay, you should always have the word processor do any footnotes or endnotes, or any page numbering. Okay, and you might say, why should I have the word processor do the footnotes for me? Why can't I do them manually? And the answer is if you have to insert a footnote in between the two, then you have to renumber the footnotes manually. Whereas if you have the word processor insert the footnotes for you using the insert footnote menu, well, then the footnotes will just be automatically renumbered for you. So you could have like two footnotes in a page, 1 and 2. Okay, if you insert a third one in the middle, then that one that you inserted has to be 2, and your old 2 has to be renumbered to 3. Well, that's a pain, because if you had like dozens of these footnotes, or you could even get up to, I've seen books with up to 100 footnotes, you'd have to go in, and then like 2 has to become number 3, and then 3 has to become number 4, and then 4 has to become number 5. This would drive you crazy. Whereas if you say to the word processor, insert a footnote here, the word processor will do that, and it'll automatically give it the right numbering. That's true for footnotes, that's true for endnotes, and actually for page numbers. Okay, so there it is. That's what you should know about for word processors. Okay, so let's go on to spreadsheets. Before I do, let me just take a quick look in the stream here. There was someone, they left, they came back, and they left again. Okay, all right. So I assume most of you will be watching this later. Okay, so the next thing we studied were spreadsheets. Oops. Okay, and so what is a spreadsheet? Recall from the lecture, it's basically a huge table. Okay, it's a table, and what is a table? A table is made up of rows and columns. Okay, so you got columns and you got rows. At the intersection of a row and a column, you've got this thing called a cell. Okay, so it's like those little cubby holes where you can put data in there. All right, and each cell, because it's at the junction of a row and a column, the cell has an address associated with the column letter. Columns are labeled by letters. Okay, so there's like column A, then there's column B, column C, column D, and so on. And the rows are numbered by numbers. So there's like row 1, row 2, row 3, row 4. And if you're at the junction of column B and row 3, then you are in cell B3, okay? Because it's at the junction of column B and row 3, okay? And that's how these cells have addresses associated with them, okay? So, like, because all the cells look identical when they're empty, how would you know one cell from another? If I were to refer to a cell, how would I refer to it? Well, I would tell you the address. I would say, go to cell B3. And you would go, okay, let me go over to column B, let me go over to row 3, and where column B meets row 3, that's cell B3, okay? And it's always the column letter first and then the row name after, okay? So these cells, when you first start up with an empty spreadsheet, they're blank, but there's 4 different types of data that you could put into them, okay? So there's 4 different types of information that you could put into them. And it's important to know this because the word processor will treat each one differently. Okay, it'll treat each one differently, and so you could just put in plain old text. Okay, so what's text? It's like letters. Okay, and if you put that into a word processor, a spreadsheet, the spreadsheet goes, oh, you just want this as a label. I'm not going to do anything special with this. Okay, so if you put like on the top of something like January, okay, because those are your January numbers. All right, picking just an example here. All right, so suppose you got some data for January and you put that at the top. You just type January at the top of a column in some cell. The spreadsheet goes, oh, okay, that you type this word in there. I'm not going to try to do any kind of arithmetic with it or anything like that. You just want it there as a label so that it's humanly readable. It makes the spreadsheet easier to read. Okay, that's one thing. Well, the spreadsheets mostly do a lot of very complicated arithmetic. Okay. Not exactly higher level mathematics, but arithmetic can be sufficiently sophisticated that you need a spreadsheet to do it, because doing it by hand would be just too tedious or too annoying. Okay, and so another thing that you could put into a spreadsheet are numbers. Okay, so what are numbers? They're basically digits. If you're typing some digits like 3, 7, 5, whatever. Okay, and that's a perfectly good number. You can have a decimal in a number, so it works with fractions, obviously. And you can have a negative or a positive sign in the front. Okay, because you might have like negative 37.5. Okay, and those are numbers. Now, the spreadsheet's going to treat numbers differently than text, because numbers, it says, oh, I can do arithmetic numbers, but you can't do arithmetic with text. Like, what does January plus February mean, right? It doesn't really mean anything, okay? But if I said, what's 3 plus 4, you go, oh, well, that's 7, okay? So that's the idea why the spreadsheet treats text data type differently than it treats number data type, okay? But there's 2 others that you should know about. Booleans. And Booleans are just true and false, okay? And the reason you need Booleans is just so that you can make decisions, okay? Like if something is true, you're going to do one thing. If something is false, you're going to do another thing, okay? That's in conjunction with the if function, which I'll show you in a minute, okay? And the last thing, I don't know if it's really a data type. I mean, in computer science, it wouldn't be called a data type, but for your purposes, you could think of it as a data type. These are functions. These are things that will calculate something, okay? And they always begin with an equal sign. The very first character in the cell must be an equal sign, okay? If you put anything else in the cell, it'll say, oh, it's one of these other types here, okay? But if you say equals sum, then it says, oh, you want to calculate a sum of something, or equals average, and then what you want to calculate the average of, it goes, oh, you want to calculate the average of something, okay? So everything that begins with an equal sign as the very first character in the cell is going to be treated as a function, and the spreadsheet goes, oh, you want me to calculate something. It'll calculate that, and it won't show you the function in the cell. It'll show you the answer in the cell. Okay, great. There you go. Now, what kinds of arithmetic can you do? Well, you could do just plain old ordinary arithmetic, which is like addition, subtraction, multiplication, and division. Okay, just be very careful. This is a typical mistake that's made with spreadsheets. Addition is obviously it's the plus sign. Subtraction is obvious. It's the little dash there. Okay, but multiplication, a lot of people will want to use the X. Okay, and you can't use the X because X might get confused with the column label. Okay, so it says, the spreadsheets don't use the X for multiplication. Instead, they use the little star there called an asterisk. Okay, so they'll use an asterisk. So if you want to do 7 times 5, okay, in the spreadsheet you would type equals, because you need equals too, 7 asterisk 5. And then when you hit enter, it'll do, 7 times 5, 35, and it'll show you the answer, 35. Okay, you can think of it a spreadsheet as just a bulk calculator. It's a calculator which can do arithmetic on bulk sets of numbers. Okay, so what's an example of bulk set of numbers? Your grades. You've got a grade for all those assignments. You've got a grade for all those tests. I got to put them together, and I have to weight them right according to the syllabus and so on and so forth. And I'd have to do that for all the students. And I'm like, well, that's a lot of work and I make mistakes. And way back when I first started teaching, I had a little paper book where I would put in grades and do that with a calculator. But you make mistakes and you have to go over it 2 or 3 times to make sure you didn't make a mistake and so on. Now with the spreadsheet, you just put the grades in there and then you say, spreadsheet, do your magic, and it just does the magic for the bulk set of grades. And well, there it is. Okay, so just plain old arithmetic like addition, subtraction, multiplication, and the division is the slash there. Okay, because there isn't that on the keyboard. There isn't the symbol with the dash with the dots on top and bottom. Okay, so but people are usually okay with that. It's the asterisk that people tend to make a mistake. Okay, all right. There are built-in functions. These are functions that are part of the spreadsheet, and they're all more or less the same across all spreadsheets. Okay, Microsoft Office, Excel, LibreOffice Calc, or even Google Docs. They all work more or less the same. Okay, and so I only did 4 built-in functions, but there's a lot of them. Okay, and the purpose of the course isn't to go through all of them. It's just to tell you that they're there. Okay, so one built-in function is called sum, and it does exactly what you think. It totals up a bunch of numbers in an array. I'll show you what an array is in a minute. Okay, so one of them is sum. The other one is average. And what do you think average does? It calculates the average of an array of numbers. The standard deviation, that might be new, although if you take statistics, you'll certainly learn about standard deviation. It measures the spread in an array of numbers. So if you have a bunch of numbers, if they're closely packed together, okay, then that's a small standard deviation. If they're spread far apart, then that's a large standard deviation. So it's basically a measure in the spread of the numbers. And then there's the if function. And the if function is basically a function which allows you to make decisions, true or false decisions. So if something is true, you do one thing. If it's false, you do something different. Okay, and like SU grades, I did the example of SU grades. Like if a grade is above 65, then you get an S. And if a grade is below 65, then you get a U for satisfactory and unsatisfactory. Okay, and if you had a bunch of grades, say 100 grades, you'd have to go through manually and go, well, that's an S, that's a U, that's an S, that's a U. What are you doing in your head? You're asking yourself the question, is this grade bigger than or less than 65? And then you write S or U on your own. But you see, the decision, rather than you making it in your head, you can ask the spreadsheet to do it for you. You do that with the if function. So it's a Boolean function, and you go right back to the beginning of the course when we had trues and falses, Booleans. Okay, so it's a Boolean function, makes a decision like that. Okay. All right. The only other thing I need to tell you at this point is that you certainly could do like calculate 7 times 5 and just go equal 7 asterisk 5, but more likely what you want to do is you want to have a function which references the values inside of a cell. And well, what do I mean by that? So if you take a look at this function here, okay, with the equal sign in front, this says something like this: go to cell B4, okay, because that's the address there. So go to cell B4. You'll find a number in B4. You'll find a value in B4. Well, where you see the B4 in the function there, replace it with its value. Okay, so suppose the value in B4 is 7. So that B4 gets replaced with the 7. And then this says, well, go to G7, go to the cell called G7 and find what value is in there. Maybe there's a 5 there. And then it would do, okay, well, I have found a 7 in B4 and I found a 5 in G7. So this says take that 7 and then add it to the 5, and it calculates, the answer 12, and then it shows the 12 to you. Okay, so these functions generally work with cell addresses rather than the values directly. They can work with values directly, but that would severely restrict the usability of your spreadsheet. It's much better to have it so that your spreadsheet can actually address these or grab the values out of the addresses of cells. Okay, so there's this thing called an array. So I mentioned them a minute ago. So all an array is it's a group of cells. Okay, and it gets annoying to have to say, you know, like I want all of those cells. Sorry, all of these cells here. You know, I want the average out of all those cells. That's a lot of typing to do, right? Rather, what you could say is I want all the cells between D3 to F5, okay? And you go, well, what does that mean? It's a block, okay? And I don't have a spreadsheet up, but I don't think we really need it for this. But you say to yourself, okay, so this block, what columns does it cover? Well, it starts at column D, and it goes all the way up to column F. So it includes cells that are in column D, column E, and column F. D, E, F. Everything from D to F and everything in between. So D and including D to F, including F, and everything in between. In other words, D, E, and F. Okay, that's the column. What about the number? Well, it says I want everything from row 3 to row 5. And say, okay, so I want row 3, I want row 5, and everything in between, so I want 3, 4, and 5. And then it's every possible every possible column with every possible row. Okay, so we've got column D with 3, 4, and 5. Okay, so there's column D, but with row 3, 4, and 5. Then we have column E with row 3, 4, and 5. And then we have column F with row 3, 4, and 5, like that. Okay, so you know, it's every column between D and F, because the first column letter is D and the last column letter is F. So every column from D, E, and F, okay, from D to F, and every row from the first row number here, 3, to the last row number 5, which would be 3, 4, and 5. Okay, so that's actually a 3 by 3 little block in the table, and it's called an array. Okay, there you go. So the reason we need to know about those arrays is because usually you're working with arrays, so you'll have something that looks like this. Okay, a function that looks like that. And so what does that function say? It says sum up everything inside. So sum up everything inside of that array. All right, and you go, well, what is that array? Well, that array is all the cells that we just discussed. Okay, so when you say sum everything from D3 to F5, that's the way it's usually read. Sum D3 to F5. Okay, sum D3 to F5. What you're really saying is add up all the values that are in cells D3, D4, D5, E3, E4, E5, F3, F4, and F5, like that. Okay, and that's how these arrays work with functions. All right, now to make it easy for you to, to make it scalable, to use our buzzword, okay, to make it easy so that if you enter the function once, you don't have to enter it again and again and again. There's this thing called a function drag. So I'll give you an example where you would use a function drag. If I write the function that'll calculate the average grade for one student, I don't have to retype that entire function for the second student, for the third student, for the fourth student. I just type the function once for the first student, and then I do a function drag across all the rows or all the columns where I want that function to actually operate, and it'll then, if I calculated the grade for the first student, it'll then calculate it for the second one, the third one, the fourth one, using the same rule. Okay, and I think you could see why that's useful, because if I had like 40 students, then I'd have to type the function for the first student and it would calculate. Then I have to type the function again for the second student and then type the same function again. It's like the same function, it's just the addresses change a little bit, because the addresses for the first function are the addresses for the first student, the addresses for the second function would be the addresses for the second student, and so on. And so by the time you're done this, you're really tired, you don't have to do that. You just type the function for the first student and then drag it for all the other students, and it automatically does the calculation for the other students as well. Now, in order for it to work that way, what you have to have is that the addresses change. And the way it works is that whenever you drag a function one column to the right, all the letters will increase by 1. Okay, so when you got a function, and inside the function there are these addresses, these cell addresses, and the cell addresses are made out of letters and numbers. The letters correspond to the columns. Okay, so if you drag the function from one column to the next column to the right, all the letters increase by 1. If you drag it over 2 columns, then it'll increase by 2. If you drag it over 3 columns, all the letters will increase by 3. So what do I mean by a letter increasing? Well, if it's D, it'll go to E. Okay. If it's F, it'll go to EFG. Okay, sorry. All right, yeah, it just goes up to the next letter. Now, I said to the right here, but if you go to the left, then it just decreases by 1. So if you were at E and you drag to the left, then the E decreases to the D. Okay, so that's what's going on with when you're dragging from one column to the next. When you're dragging, so I'm going. It looks like I'm doing a row here, but the function is in one column here, and I drag it over to the next column here. Here's the next column. Then I drag it over the next column there. Okay, so when you drag a function from one column to the next column to the right, the letters increase by 1. And if I dragged it to the left, the letters would decrease by 1. The numbers would stay the same. Okay. And what about dragging the function down a row? So if you drag it down a row, because the rows increase going down, you drag it down a row, all the numbers would increase by 1. The letters in the cell addresses stay the same, but the numbers increase by 1. Okay, so if you had something like D3, here, let's take this example here. You had something like D3, all right, or better yet, right there. Okay, if you were to drag that function down, D3 would become D4. The D would stay the same because you're not dragging across columns, but the 3 would become a 4 because you're dragging across rows. You're dragging from one row to the next, okay? And similarly, the F here would become F6. The F would stay the same because you're not doing a column drag, you're doing a row drag, and the number 5 would become a 6, and so on, okay? And you should have seen a lot of those examples in the assignment, okay? And there'll be some similar examples on the test. All right, so there you go. This is what happens, and you want that to happen by default, okay? Because that's why the functions work the way they do. Whereas if you have got like one row of students, it's got all the grades are in one row, and then at the end of that row you have the function for calculating the final grade. Well, then the next student is in the next row. You drag the function down a row, all the numbers in the addresses will increase by 1, and now they'll refer to the second student. Then you drag it down again, now they refer to the third student, and so on. And that makes it just so much easier. Okay, so by default, you want the letters and the numbers to change. But you might say, well, what if I don't want the letters and the number to change? And that's what this $sign is all about. If you put a $sign in front of the letter, then the letter won't change, but the number can. If you put the $sign in front of the number, then the number won't change, but the letter can. Okay, so there's two parts to the cell address. There's the column letter and the row number. Okay, if you don't want the column letter to change, but you don't care about the row number can change, but you do not want the column letter to change, you put a $sign in front of the column letter. That's what I did in this example here. Okay, so that D cannot change. Why? Because the $sign in front of it freezes it. No matter how I drag this thing, okay, the 3 can change. All right, that can change. The F can change. The 5 can change depending on how I drag it. Those are free to change by the rules I just gave you. But the D is frozen. It may not change. Okay, like that. All right, so there you go. If you don't want the letter to change, put a $sign in front of the letter. If you don't want the number to change, put a $sign in front of the number. And maybe, it's worth saying, what if you don't want either of them to change? Okay, so here's another example. All right, what if you don't want the D or the 3 to change? Well, then you can put a $sign in front of the D and the 3. Okay, in that case, the D can't change. The 3 can't change either. Only the F and the 5 can change, okay, by the rules that I just mentioned above, okay? So basically, to stop the function from changing, you just put a $sign in front of the letter or the number so that it doesn't change, okay? There we go, all right? And there was some more stuff about spreadsheets. I mean, this summary is more or less meant to get you thinking about the important stuff, but reread, the summaries. I mean, you can even rewatch the lectures. It's up to you, but if you reread the summaries to those sections, they pretty much cover everything that you'll need for the final test. No, let me take that back. They will cover everything you need. Okay, there'll definitely not be anything on the final test that isn't already in the notes. Okay, last thing we studied was databases. Okay, and I could see from the assignment that there's one thing. People generally did well, but there's one thing that I think I lost a lot of people on, and it won't be on the last test. Okay, I might have pushed it just a little bit too much, and that is, how you use primary and secondary keys to create the relationships by moving. Where do you put these keys inside the tables? Okay, I do expect you to know about primary and secondary keys, but I don't expect you to actually say, okay, we'll take this primary key from this table and put it into the secondary as a secondary key in that table in order to create a one-to-many relationship. Okay, so that seemed to confuse some people. Okay, like, why did you have to? I think what confused people was like, why from many to many relationship, why did I have to introduce this third table? Okay, so in retrospect, I wish I hadn't gone into that deeply into it. Nonetheless, the rest of the stuff on the databasing you need to know, and it's really good to know about in life, even if you never design a database. And the reason is that if you think about what I taught you here with databases, when you go out into the real world and you're working in whatever environment, say a hospital environment, you're going to see all these numbers all over the place. They're all of a sudden they're going to start to make sense in terms of like how all of the information in your organization is organized. It's like the database is like this mirror replica of the entire organization. So there's this entire organization there, and it does its things with like patients and there are patients, there's doctors, nurses, there's room numbers, and all this kind of crazy stuff. And these things get associated with one another, and you realize that all of this kind of association, you know about it because you go into your computer and you're typing away in your computer, and your computer says, oh, there's an MRI machine in this room. This room can't be used for like, I don't know, it doesn't have blood pressure cuff or whatever, but this one does. All those kinds of things. You go, well, how is it doing this? It's all by these magical associations of numbers that are happening inside the database. So the database inside the computer is like this mere replica of what the real world is. Okay, presuming that one, the database was designed well, which sometimes isn't the case. Okay, and number two, that people entered the data right. But assuming that those are the case, then your database is this perfect replica of like how your organization works. Okay, and so even though the databasing stuff may seem like, wow, you really pushed us on that, but if you understand this, suddenly like your entire system that people sometimes get confused with, like people get confused when they're using their databases, that confusion will go away. Okay, and because you'll understand what's going on behind the scenes. Even if you didn't design it, you'll still have those principles in mind. And that's what this section was all about, to make sure that when you're out in the real world, you can understand how those internal database designs reflect the external organization that you're part of. Okay, well that's enough for selling it, but I think it was kind of important, so you don't think that this knowledge is just purely academic. It's real world stuff. Okay, anyhow, let's jump into it. Okay, so databases. This whole section was about making your work easier, and there's this buzzword in the field, scalability. Okay, and what scalability means is like, how much more work is it if I increase the number of data items that I have to process? Okay, so what do I mean by that? Like, suppose you've got like 5 patients, okay, and you got to like do their charts for 5 patients. Well, if I double that to 10 patients, how much extra work do you have to do? The intuitive thing is that double the number of patients, double the amount of work, but not always. Sometimes you double the number of patients and it's still the same amount of work. And you go, wait, how is that possible? Well, remember the example of the letter that you're writing to 500 people? You only write the letter once, and then the database populates all that information for you. So you only wrote the letter once. You only wrote the letter once, whether it was for 5 people or 500 people. That's amazing. It's the same amount of work to send a letter to 1 person, to 5 people, to 500 people. When you're in that kind of a situation, that's really good scaling. When you're in that kind of a situation, you have an order 1 operation. And what that means is that the amount of work that you have to do doesn't change no matter how many data items you're processing. I say data items, or sometimes I'll just say items. An item is like whatever you're for patients, like in my previous example. Each patient is like an item, okay? And so, if you're writing a letter, and you're using this merge technique that I just mentioned and demonstrated, then it doesn't matter whether you're writing it for 1, 5, 500, it's the same amount of work. So the amount of work doesn't increase as the number of data items increases. Okay. Now there's order n operations, and these are the most typical ones. You double the amount of data items, double the amount of data, double the amount of work. Okay, twice as many patients, twice as much work. Okay, 10 times as many patients, 10 times as much work. Okay, those are called order n, and that's usually the way things scale. If things are scaling order 1, you're doing really well. Okay, if things scale order n, and that's typical. Okay, it can get bad though. You can have things that scale as order n squared, and what that means is if you double the amount of data that you have to process, you actually quadruple the amount of work that you have to do. Okay, and that's usually because of a cross-referencing. I don't want to get into the details of it. Okay, so you've got 5 patients and you do so much work. You've got 10 patients, you actually have to do 4 times as much work. And you go, well, I doubled the number of patients, but I actually do 4 times as much work. What's the relationship? Well, it's the square. 2 squared, double squared is quadruple. That's what's going on. Okay, so there you go. So there's order n squared possibility too. Okay, and there's others. I don't want to give you everything, but things that scale well are like order 1. Things that scale poorly are like order n squared. So what's the point of the database? The point of the database is to make your life easy. It's to try to make things scale as easily as possible. All right, so that the amount of work that you have to do in the office is as low as possible. It scales as best possible. Okay, all right, now let's get into the internals of a database a little bit so we understand what's going on inside of them. Okay, you can't put all of your data into one table. If you can, you don't have a very complicated organization. Okay, generally you need multiple tables to be able to represent the data of your organization. Okay, now when you have if you try to put all of the data of a complex organization into one table, you get these things that are called anomalies. All right, and without going into the detail, I did show you an example of an anomaly during the lecture on this section. Without getting into those details, basically all you need to know is that if your database has an anomaly, then things start to get weird. Things start to get confused, like in terms of how things relate to one another whenever you insert data or you delete data or you modify data. Okay, so like you insert a patient into your database and later you go to look up that patient and it said, I inserted this patient before, where did they go? All right, or you delete a patient and then they're still there in the database. Or you change the person's, like you misspelled the person's first name, you change it, and the misspelling is like, sometimes it shows up right, sometimes it doesn't show up right. You go, what's going on here? Why is the database doing that? It's because it's got an anomaly. Okay, there are an anomaly or anomalies in the database. And basically, it's not a mistake in the data. It's a mistake in how the database was designed. Okay, so an anomaly is basically a flaw. An anomaly is a flaw in how the database is designed. The flaw doesn't show up right away, but it starts to show up as you begin to insert data, delete data, or modify data. Okay, and you are guaranteed to have anomalies if you try to just put everything in one table. Okay, don't want to try to prove that for you, but that's why you have to have these multiple tables. All right, in a database. So what is a database? A relational database. Okay, that's where the tables are related to one another. Basically, a relational database is a set of related tables. Okay, so it's like more than one table, and the tables relate to one another. That's it. That's what a relational database is. You say, well, why do I have to have multiple tables? To avoid the anomalies. Okay. Now, there are different ways of designing databases, and that's so far beyond the scope of this course. I just want you to get at how most databases are designed, especially for organization. It's what's known as the entity relational model. And basically what you do is you think about your organization in terms of entities. Those are the things that your organization works with. Let's pick on the hospital example. Patients, doctors, nurses, okay, rooms, okay, things like that. Okay, those are the entities of your organization and how they relate to one another. If all you had were the entities, you'd have like patients and you'd have doctors. But like, is there any relationship between patients and doctors? You got to relate them somehow. Okay, so that's why it's called an entity relational model, because they're the entities and the tables represent the entities, and then there's the relationship between the tables. Okay. All right, so how is each table organized? It's pretty intuitive. Each row in the table, so the table itself represents like a category of entities, okay? So, like you have the patient table. And what's that? What's your patient table? That's where all your patients are, Okay, that table contains all the information about all the patients in the hospital. All right. So each row of the table, though, is one particular patient. It's one particular entity. So you got like one patient, and you got next row is another patient, next row is another patient. Okay. The columns of the table, because remember, tables are made out of rows and columns. Okay. The columns are the attributes. Okay. So you say, well, what characterizes a patient? Well, all patients have a first name. All patients have a last name. You know what? I kind of wish I put that in there, but you know what's a popular, because I've got an example here. A popular thing is birthday. Usually when you call a doctor's office or hospital, they say, what's your birthday? They look you up by birthday. Okay. But you say, so those are the attributes, like first name is an attribute, last name is an attribute, birthday is an attribute, and those are the columns. Okay. So I've got here highlighted just a very simple table. So the table is basically a patient table. And who are my patients? Well, the first patient is Fred Flintstone, and the second patient is Wilma Flintstone, and the third patient is Barney Rubble. And so you say, well, okay, first patient, what's their first name? Fred. First patient, what's their last name? Flintstone. Okay, you see how that's organized. Okay, now there's the patient table. There'd be something presumably the same for a doctor table somewhere else. And you say, well, how do I relate the two? That's where these primary, secondary keys come in. The primary keys are like the ID number. Okay, and these primary keys, they are basically the unique identifier in the table. Okay, so the primary key, I guess I said it here. Primary key is a unique identifier for every entity in the table. All right, so what is the unique identifier for Fred Flintstone? Number one. He is patient number one. Okay, so what is the unique identifier for Wilma Flintstone? She is patient number two. All right, and if I asked you who is patient number three, you would say patient number three is Barney Rubble. I couldn't have two patient number twos, because if I said to you, who's patient number two, you'd be confused. You'd be like, well, is it Wilma or is it Barney? And that's why this has to be a unique identifier. Every patient has to have their own unique number. Otherwise, you're confused, okay? Or, student ID number. Every student has their own unique ID number, because if every student if two students had the same ID number, and you had to look up that student, you get two names, and you go, well, which one do I pick? Okay, so that's the primary key. The primary key is the unique identifier for the table. In this case, it's the ID field, like that. Okay, and you say, well, what am I going to do with these primary keys? Like, I've got these primary keys. That kind of makes sense that all patients have ID numbers, and what's the point of that? Well, they're used. The primary keys from one table are used with primary keys of another table to create associations. That's how the relationships are made. Okay. Now, when the keys are exported out of their table into another table, they're called secondary keys in that other table. Okay. And so the primary keys are basically the unique identifiers. The secondary keys are basically the pairings of primary keys in another table. So I hope that's not confusing, but I thought to myself, well, I better give you an example so that you know like what I'm talking about. So imagine that you have a patient chart. Okay, and again, this hospital example, you've got a patient chart. So what do you think's on that patient chart? Well, one thing that's on that patient chart is the patient ID number. The chart isn't the patient, but the chart references the patient. What else might be on that chart? The doctor. Okay, and so now here's this chart, and what does this chart have? It has two numbers. It has the patient ID number and it has the doctor ID number. And by putting the patient ID number and the doctor ID number side by side, it's creating an association. The patient ID number in that chart is called a secondary key, and the doctor ID number in that chart is called a secondary key. The secondary keys are what are creating the relationships between the entities. Okay, so never mind whether you do it with creating a third table or whatever. That's the part that I think I pushed a little bit too far. I think it's much more important that you understand that these primary keys, what they're used for, they're used in conjunction with other primary keys to create the pairings, to create the association, the relationships. So now I think you can see how a database basically works. It's got these tables. Each table, the entities relate with one another. The entities are related with one another by pairing the primary keys together in the secondary key fashion. Okay. Now, one more thing. It's a little bit theoretical, but I thought it's probably important that it be there. It's this idea of cardinality, and I didn't use that word too much, but it's basically whether the relationship is one to many or many to many. Okay, and that is kind of important because it says something about how these keys get associated with one another without going into the details like I did in that lecture that I think might have been a little bit over the edge. But let me just give you an example of a one-to-many relationship. Okay, so you've got two entities, and those two entities might be in a one-to-many relationship. And you say, well, how does that work? Well, people live in houses. Okay, so we've got a so this is a different example. Okay, so we've got a people table and we've got a house table. So the people table basically has a list of all the people, and the house table has a list of all the houses. And this is how it works. A person lives in one and only one house. A person lives in one and only one house. Okay, but a house can have many people living in it. All right, makes sense. All right, I know that in the real world, you could have like a summer and winter residence, but we're not rich, okay? I just live in one house, all right? And most people just live in one house, okay? So each person lives in one house, but a house might have many people living in it. That is known as a one-to-many relationship. Okay, and your organization probably has a whole bunch of one-to-many relationships. All right, it's unlikely that a patient only has one doctor, but it could be. Okay, maybe like in a hospital setting, one and only one doctor is associated with a patient. So a patient has only one doctor, but the doctor might have many patients. Okay, so a doctor seeing many patients, but taking any one of those patients just has one doctor that is responsible for them. Okay, so there's an example of a one-to-many relationship. All right, and the other type of relationship is a many-to-many relationship. Okay, and that's a situation where one entity relates with many either way. Okay, so I took here the example of students taking classes. I put person here, but let me put student, guys. Why not? Okay, so a student can take many classes. Okay, you could take one, but you could take more than one. Usually you're taking four or five, maybe 6 classes a semester. So a student can be in many classes, and a class, and a class can have many students in it. Okay, so a student can be in many classes, and a class can have many students in it. That's an example of a many-to-many relationship. Okay, and again, your organization may have many different many-to-many associations. Now, I don't want to get into the details because, like I said, that was pushing it a little bit. But this actually does cause confusion when people are using these databases. So right now, even though you're not sure where you would see that in the real world, just keep this in the back of your mind. And trust me, when you're out in the world and you're working with databases, like say in a hospital setting, you're going to notice that how the database treats these one-to-many relationships are different than how the many-to-many are treated. Okay, and you'll see that in the forms, you'll see that in the queries, and so on. And so it's kind of important to just know that these two different types of relationships exist. Now there's variations on them, but let's not go there because this is good enough. Okay, now last thing, once the database is designed, what do you do with it? Okay, well, once the database is designed, you can enter in data. You want to enter in the data, all right? And just say here, you use a form to do that. Where did I say that? Yeah, right there. Okay, so we got this data, a database. The database is designed, this thing called a schema, like how the design, a schema and design are kind of synonymous with one another. It's like how all the pieces relate, but there's no data in it. It's like you've got all this place where you can put patient information, but you got no patients. You've got this place where you can put all this doctor information, but you got no doctors. So the procedure by which you enter these are called forms. Okay. Now I didn't show you forms in the lecture because I really didn't want to get too far out of the main theory of databases. But basically, like a form is just ways in which you can enter things, and not only enter in the data like patients, but also associate those patients with the doctors that are seeing them. Okay, and so these are called forms, and they're a little bit more than just like entering in, just data entry. It's data entry plus making the relationships between those entities and other entities in the database. All right. So you got all this data in the database, and like, why'd you put it in there in the first place? You wanted to track it. Well, why do you want to track it? Because you want to ask questions of the database. Okay, and those questions are called queries. All right, and I did show you how queries are done with in the lecture. Okay, and so the kind of question you might ask, and there's millions of questions that you can ask because it depends on the database, but you just ask, how is this thing related to that? Okay, and those are called queries. And so uh, you know, you might ask a question like, what doctor is treating Fred Flintstone? Okay, or if it's a doctor patient is many to many, you could ask, what doctors are treating Fred Flintstone? Okay, and or here's an even better one. We didn't talk about medicine, but pharmacies have to look for medication that interact with one another, and so you might say, well, what medicines is this patient taking? And are there any interactions between the medicines? Okay, and so those are the kinds of questions that you can ask of a database, and those are called queries. And then and this is the last thing: how are queries actually processed by the database? And the way it's done is by doing these things called joins. All right. Now I had two different types of join that I gave you. There's lots of different types, but there's two that I want you to know about. Okay, so there's this thing called a cross join, and what a cross join is like you've got patients and doctors, and you literally match every single patient to every single doctor, every possibility. And you say, well, but that's not the reality. It's not like Fred Flintstone is being treated by every single doctor. Okay, or Wilma Flintstone, she's not being treated by every single doctor. That's right. This cross join, which matches every entity from one table with every entity of another table without any kind of matching of the keys. It's like the primary, secondary keys, they don't even exist. It's like, the database says, oh, you want to cross join. I'm not even going to look at the primary, secondary keys. I'm just going to match every single patient with every single doctor. And you say, well, what good is that? Why would I want all this extra information that's not real? Well, because it isn't so much that you use a cross join for the reality. Cross joins are used for possibilities. They'll show you every possible relationship between patients and doctors. So, Fred is maybe not being, looked at by doctor number one, but could be. All right. And Fred is not being looked at by doctor number two, but could be. Okay. So this is kind of, the cross join is kind of like the space of all possibilities. All right. Sometimes you want that, but not usually. Usually you want the actual relationships. And so out of the cross join, you can slim it down to just this thing called an inner join. And what the inner join is match all the entities of the two tables, but only where the keys match, only where the primary and secondary keys match. Okay, and so that's not the space of all possible relationships, it's the space of all actual relationships. So you go, okay, well, Fred Flintstone, are they being treated by doctor number one? Well, do the keys match? They don't. So Fred is not being looked at by doctor one. Go to doctor two. Is Fred being treated by Dr. 2? Well, do the primary secondary keys match? No, they don't. Okay, well then Fred is not being treated by doctor number 2. Could be, so it's part of the cross join, but isn't in reality, so it's not part of the inner join. Okay? And then is Fred being treated by doctor number 3? The primary secondary keys match. So we have a match between the primary and secondary keys, and so yes, Fred is being treated by doctor number 3. Okay, and so that's the space of actual relationships in your database. All right, so that's why I gave you both joins. Okay, and it depends on what kind of query you're asking, but usually you're asking for the inner join because you're asking like, who is actually treating Fred? Okay, I don't want to know who could possibly be treating Fred. What doctor is actually treating Fred? And that's an inner join. Okay, if I were to ask the question, what are all the possible doctors that could be treating Fred, or what are all the possible doctors that could be treating all possible patients, then you'd be asking for all possibilities. That's your cross join. Okay, and that's it for databases. If you're thinking to yourself, this doesn't feel complete, like you wouldn't be able to go out and get a databasing job, designing databases. That's right. I had to, as a teacher in this course, I got to ask myself, well, this knowledge that I've given you in the entire course, and not just databases, has to be practical for you, into the future, like, something that'll carry you through life interacting with computers. And so this, I think, is sufficient so that when you go out into the real world and you're interacting with an organization, you're in a hospital setting, okay, or I've just been picking on hospital, but any kind of business, and you're using these databases, this will help you to make sense of why the database is working the way it is, what's going on behind the scenes a little bit. Okay, well, that's it for the test number 3, and that's it for the course. Okay, so uh, well, goodbye. I'll take a look uh, in the chat here. Nah, there's no one in the chat. That's okay. I'm sure you'll all watch this later. Okay, bye bye.